Lesson 29 is just simple Pythagorean theorem, okay? So this should be a quick set of notes. It should also be a quick lesson. So just a reminder, Pythagorean theorem looks like this. A squared plus B squared equals C squared. A and B are legs of the triangle, and C is the hypotenuse. Okay, so reminder, Pythagorean theorem only works when you have a right triangle. Okay, the legs are simply the left and right sides of it. Okay, and the hypotenuse is the long piece right there. Okay, so this is a leg, and this is the hypotenuse. Okay, any questions over those definitions? All right, I figured there would be. So there's a thing called a Pythagorean triple. It's basically just a perfect triangle that doesn't give you any decimals, it gives you whole numbers. The most common one we'll see is called a 3, 4, 5. So example 1 goes over a multiple of that Pythagorean triple, 3, 4, 5. Now the reason this is a Pythagorean triple is because when I plug it into the Pythagorean theorem, I get 3 squared plus 4 squared equals 5 squared. And this should turn out true. 3 squared is 9, 4 squared is 16, and 5 squared is 25. And it turns out that 9 and 16 together make 25, so it checks out. It follows through, and there's no crazy decimals or square roots that you have to do. So perfect Pythagorean triples fall into the category of they are whole numbers for all the side lengths. And all multiples of this will work too. So for instance, if I multiplied each one of these by 2 and got 6, 8, and 10, that's a multiple of 2. And if I did the Pythagorean theorem on this, I would also, again, get a perfect one. So I'd get 6 squared plus 8 squared equals 10 squared, hopefully. 10 squared is 100, 8 squared is 64, and 6 squared is 36. When I add those two together, I get indeed 100. So it works out. So what they want you to do, if they say confirm something as a Pythagorean triple, you just plug it in and make sure. Remember, the hypotenuse, make this little note, is the longest side. Every single time it is the longest side.
Like when you're doing factoring, whatever it is, and you have like 10 and then equal 10. It's like, what do you call it?
Comes true.
Comes true? Something like that.
Yeah. In essence, yes. Except we won't be doing infinitely many solutions. We'll be doing, this is just checking to make sure that it's true. If you get something that ends up being true at the end, you just write, yes, it is a Pythagorean triple. Okay, so let's do the example that they give us on 1. It says, find the unknown length of the triangle and do the side lengths form a Pythagorean triple. So they give us this triangle and say that the sides are 15 and 20 centimeters each, right? And I don't know what this side is over here. They label it x, so I'll just use x. So I go leg squared plus leg squared equals hypotenuse squared. Okay? Leg squared plus leg squared equals hypotenuse squared. And I just start squaring things. You can use your calculator. I want to show you guys this button if you don't already know where it's at. If I press 20 and then press the x squared button, it'll do x squared. Okay, it's right below. It's about midway in your calculator. Okay, so I just type x squared and it should pop up that, and then you just press enter. It pops out your answer. Okay, so that'll be 400, and then 15 squared is 225, and it should equal x squared. Then I just add these two together. I get 625 equals x squared. How do I get rid of a squared? I square root it. And what I do to one side, I must do to the other. So I've got that done. X squared and square root cancel it out. So the square root, just in case you don't know where square root is on your calculator, it is second that x squared button right there. 625, my bad. 625, close the parenthesis, press enter, it's 25. So since this is a whole number, notice that all of these are whole numbers. Is this a Pythagorean triple? Yes, it is. All of those end up being whole numbers. It is a Pythagorean triple. Okay. Any questions? Okay, I want you to notice that this was 15, 20, 25. And look at that Pythagorean triple 3, 4, 5. I multiply this one by 5, I get 15. Multiply this one by 5, and I get 20. Multiply this one by 5 and I get 25. They're multiple. A lot of your Pythagorean triples will be multiples of that 3, 4, 5 triangle. That'll help you down the road, trust me. Alright, so this one's not a perfect Pythagorean triple, but we can still use the Pythagorean theorem because it is a right triangle. So it's 24 inches. Oh, I forgot my label here. It's centimeters. Sorry. Anyways, 24 inches. And then the hypotenuse is 26 inches. And my unknown, they labeled it x, so I'll label it x. And I start plugging in. I have leg squared plus leg squared equals hypotenuse squared. I almost wrote inches. Okay, and I just start solving it. So I do 24 squared, which is 576, plus, I don't know what x squared is yet, 26 squared, 676, thank you. And then I start solving like I would normally. I get all my variables to one side, and I get all of my regular numbers to the other. So I'm going to subtract 576, That goes away. I'm left with x squared equaling 100, right?
Yeah.
So I need to do what? Oh, I said this wasn't going to be a Pythagorean triple, but it might be. So that square root goes away. I'm left with x. What is the square root of 100? No. What times itself is 100?
1.
Okay, if we don't know our square roots, then we simply type it into our calculator. The square root of 100 is indeed 10. There we go. So, since this is a whole number, and all of these are whole numbers, is that a Pythagorean triple? Yes or no? Yes, it is. So, yes, it is a Pythagorean triple. I didn't think it was going to be. Lucky us. So that was example 2. Let's go to the next example of... Oh, I did. Thank you. Inches. Thank you, Marie. All right, we're going to start seeing things in these square roots. We're going to start seeing things in the form of square roots because not all of these are going to end up being perfect. So when I say radical, think square root. Okay? When I say radical, think square root. All right. On part B of that example, it gives us another right triangle. Okay, here's our right triangle. It's labeled 5 foot, it's labeled 10 foot, and an unknown, which they give us as x. So I go leg squared, which is 5 squared, plus leg squared, which is x squared, equals hypotenuse, which is 10 squared. Start evaluating at 25. We don't know what x squared is yet, and 10 squared is 100. I subtract 25 for both sides, and I get x squared is equal to 75. I square root it. Gets rid of my squared. I'm left with x equals the square root of 75. Now, this point, you have to start asking yourself, how can I simplify this? They're going to say, write this in simplified radical form. So there's a rule. So here's your little side note. There's a rule. If I have the square root of a, just some random number a, multiplied by another square root, say b, then it's the same as the square root of ab. Now let me explain what that means. If I had the square root of 4 multiplied by the square root of 3, that would be the same as the square root of 12. Okay? Any questions on that rule? Now what we're going to do is we're going to pull it apart. So if this is the square root of 4, we know what the square root of 4 is, right? What is this? It's 2, right? So I'm left with 2 square roots 3. And this is how we'll write our answers, is like this. Okay? So it allows us to simplify our radical. So I want to think of factors of 75 that are perfect squares. Now when I talk about perfect squares, I mean 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Then it goes on, 36, 49, 64, 81, and 100, 121, 169, and so on, 169, not 66. Okay, so all of those are perfect squares. So are any of these numbers factors of 75? Any of the perfect squares that are factors of 75? Not quite. 25 is a perfect factor that will go into 75, right? It's a perfect square that will be factored out of 75. 75 divided by 25 is what?
3. 25 times 3.
25 times 3, right? It's just like quarters. 25, 3/4 will give you 75 cents. Okay? So I can simplify this. So x will be, what is the square root of 25? 5. And I don't know what the square root of 3 is, so I just leave it. This is in simplified radical form. So if they said, I'm going to do another example of breaking down something into simplified radical form. If I give you the square root of 117 and said, find the simplified radical expression, then you need to go over here to all these numbers. And what I've done in the past, there's another way to do it that I learned, but we'll learn later. But what I've done in the past is I just take the number and I start dividing it. I say, okay, I'm going to divide it by all the perfect squares. So I don't divide it by 1. You don't need 1. That one's silly. I start dividing it by 4. See if it works. It didn't work. 117 divided by 9. Let's see if it works. Hey, it worked. So that's one of them. So it's the square root of 9 and 13, because 9 times 13 gives me 117. And then I break it down. I'm left with 3 square roots 13. I'm going to give you another one. And this time you have to do it for me. Square root of 845. So I have to go through these numbers. I'm going through these numbers to figure out which one divides into 845. Okay, so I heard that we got 169 to go into there, which is the 13 squared function, right? So I got the square root of 169 and the square root of 5 left, because 5 and 169 make 845. So the square root of 169 is 13. I'm left with 13 square roots 5. And I expect you to be able to write your answers in these kinds of expressions. So if you're not paying attention, because I know you haven't seen this before, you're probably not going to get them right. All right, moving on. Example 4. Application of TV aspect ratio. All TVs are created in a certain aspect ratio so that every single television channel can put it on any screen and it won't look distorted, or it won't look changed. So when you see TVs that say widescreen, it's because they're created for a certain purpose. Okay? So the aspect ratio of a TV screen is the ratio of the width. I'm going to draw a little TV on here real quick. It's the ratio of the width to its height of the image. Find the height to width ratio of a 42-inch TV screen with an aspect ratio of 4:3 to the nearest tenth of an inch. The length of 42 inches refers to the diagonal distance across the screen. Did y'all know that? This is true. A TV's measurement is from one corner to the other corner. It's not how literally wide it is. So if you say, I wonder if my TV will fit here, and you measure 42 inches, that's not going to be an accurate measurement. All right, so we have a width and we have a length. If I broke this into a triangle that is just this part of the TV, this would be a leg, and the 42 inches would be our hypotenuse, right? So if it is a 4:3, right, if the aspect ratio is a 4, like the width would be a 4, to the height, which is 3, and the diagonal is 42, we need to find out what it would be. So looking at the triangle that I'm about to create, the original aspect ratio was 4:3. So if this is 4:3, what is my hypotenuse? That's what we need to find. So I use Pythagorean theorem to find that. So a squared plus b squared equals c squared, right? So 3 squared plus 4 squared equals x squared in this case. So I get 9 and I get 16. Did anybody notice anything right away? No? All right, I'll point it out to you at the end. 9 and 16 make what? 9 and 16 make what? Thank you. So 25 equals x squared. I square root both sides to simplify this. X equals 5. So what kind of triangle was the aspect ratio of this TV? A 3, 4, 5. It is a Pythagorean what? Triple, right? It's one of them perfect ones. So basically, these should all be multiples of 3, 4, and 5. So therefore, the hypotenuse should be the multiple of 5, in essence, right? So we need to make sure that we answer the question. It says to find what? To the nearest tenth of an inch. So we need to find the height and width of a TV to the nearest tenth of an inch. Now there's a bunch of ways to do this. We can do this as a ratio. Okay, we have two triangles that we know are multiples of each other. So I can say that 3 goes with my height. So 3 to my height, as 5 is to my hypotenuse, right? So 5 is to my hypotenuse of 42, and then I could solve it that way. That is fine by me. So I do my cross multiplying, I get 5h. Do my cross multiplying here, and I get 126. Divide by 5. It's 126 divided by 5. 25.2. This is in inches, so inches. And I set up the other one the same way. I have 4 is to my width, as again 5 is to my hypotenuse. These are in corresponding places. They're similar to each other, not congruent. So again, 5w. Oh, sorry, that's supposed to be 42. I don't know why I wrote that like that. 5 is to my hypotenuse of 42. So 5w and 42 times 4, which is 168, I think. I divide that again by 5. 33.6 inches. So there's my height and my width.